2D signals. Now, 2D signals are defined as non-3D signals, meaning non-mass spec signals, that are often used in conjunction with mass spec. For example, in LC-MS/MS, it's often the case that you're bringing your methods from an LC detector like a UV detector, and then you're going to create a mass spec method from that. So having the UV signal is extremely important as a reference and as a confidence builder that your method is working out. Let's take a look at the application. Here we've got a mass spec method. As you can see, the MRM transition here. And if I look at the corresponding ISTD, I'll see its transition. And what I'm going to do here is demonstrate how I can have a mass spec method along with its sister UV method, and I will show you how to set up UV quantitation. So what I'm going to do right now is go over to the method editor, and as I said, here I've got my MRM with the transitions that I'm used to. But next I'm going to go down to Advanced Tasks, Compound 2D Setup. And I'll see now that I have some other choices, and I'm going to convert this mass spec method to a UV method by changing the signal type and then changing the signal type. So now you'll see that the title talks about variable wavelength detector. Now you might ask here, what happens if I have multiple wavelengths in my variable wavelength detector? And you will see that here as a choice. In this case, there's only one defined, A, but if there were others, you will get the choice. And you can make that choice here. And I will mention that in some instances, you can have two detectors that are identical with slight variations, and in that case, you would define the instance here. That is defaulted to 1, and I'll just leave it as null, which defaults to 1. So there I have created my UV 2D signal quantitation method. Let's go over and apply that method, and then analyze this batch, and we'll look at quantitation that has happened with a 2D signal. So you'll notice down here, there is the 2D signal, variable wavelength, and I've got a different curve here for the compound as analyzed with a 2D signal.